Hello everyone. I Shubhra Banerjee from Reno University and to give a presentation on radiopharmaceuticals. Do you know what is radioactive molecule and what is pharmaceuticals? Radioactive molecules are those substances which can disintegrate some of the particles like alpha particle or beta particle or some of the electromagnetic rays spontaneously in an unstoppable manner, and they have the known as the radioactive substance. And these radioactive substances have been used for the pharmaceutical or different medicinal purpose or for diagnostic purpose. So they will be used different medicine or pharmacy purpose, which will be discussed in this chapter. Now, first of all, you should know what is radioactivity. By definition, if we say the phenomenon in which the nucleus of the atom of an element undergoes spontaneous and uncontrollable disintegration or decay, that is emitting alpha, beta or gamma rays. So this is a phenomenon, this is an activity. Some of the elements which is found in the periodic table or found in nature that have the ability to emit this type of radioactive elements, radioactive rays. So this is the process of spontaneous disintegration of the nuclei of heavy metals or elements with the emission of certain type of radiation. Okay. So the emitted alpha, beta and gamma rays from unstable nuclei are collectively called the ionizing radiation. So whatever the alpha, beta and gamma जो particles जो release हो रहे हैं, this is forming a unstable nuclei. As a result, the radioactive elements will produce some unstable nuclei, and these rays will be called as the ionizing radiation. Depending on how the nucleus loses its excess energy, either a lower energy of the atom, same form will result, but a completely different nucleus or atom can be formed. Whenever the element will radiate some of the alpha particle, so they will produce some same atom or the atom with lower atomic number or mass number, and some of the particles, helium particle or the neutron, electrons will be generated. Okay? So I'm going to the natural activity. So radioactivity is classified into two categories. One is natural radioactivity, one is artificial radioactivity. So this is a spontaneous process that is without any external means or by itself disintegration of the nuclei of the heavy metals with the emission of the radiation. So they are unstable nuclei found in the nature. So without any effects, they are producing radiation without any external means. Okay. So this is an example of the molecules which show the radioactive elements. The elements whose nuclei is spontaneous disintegration all the radioactive. Okay. So this is the uranium, whether 92 and 238, the atomic mass number. It produces thorium that is forming 92-34. As a result, a helium or alpha ray will be alpha particle will be produced. Actually, alpha particle is known as the helium. Okay, so they have the 2 and 4 atomic number and mass number respectively. The thorium, this is reduced to palladium. As a result, 91 atomic number and 234 will be the same. So electron number has been, the atomic number has been increased. That means one electron has been released. So this electron is known as the beta ray. Now from the radium, thorium is again released. This is one of the isotope. So that's why 88, 26 and 226 to 222. And as a result, one particle of the alpha particle or helium will produce. So these are the example of the natural radioactivity. Now coming to the artificial radioactivity. This is a process in which stable or non-radioactive nucleus is changed into an unstable radioactive nucleus by bombarding it with an appropriate atomic projectiles like alpha, neutron, and proton. That means some of the natural process which will show a different radioactive molecule will be handled through the different external members which will be bombarded and it yes, as a result it will show the radioactivity. This is artificially formed radioactive with alpha particle or neutron or proton. Okay. Next, I'm going to the next slide. This is an example of the artificial radioactivity. So this is aluminium, which is bombarded with the helium, and it is forming whatever the phosphorus, which is a radioactive molecule, and as a result, a neutron will be also released. A boron that is heated with the helium will be producing a nitrogen, a neutron will be produced. From the nitrogen, it will also produce a carbon, that is the radioactive carbon, which will produce the electron. That is a very, these nitrogen, phosphorus are having the uses in the radiopharmaceuticals, and carbon C, you can know this is used for the different detection of age of some old material like foods, fossils derived from the seas. Okay, so these molecules will be easily handled because they are easy to prepare the radioactive product. So the difference between natural radioactivity coming under exam, that's important. You can differentiate very easily. By definition, you have to show the natural and artificial. Then it is uncontrollable, hence it cannot be slowed down or accelerated by any means. And this artificial radioactivity can be controlled by the speed of the particles and used for bringing about the artificial radioactivity. It can be controlled. Okay. Usually shown by the heavy metals, or for the artificial radioactivity, it can be shown by the light metals. I think up to clear you have this topic. Now there are units of radioactivity. How can you measure? So this is the standard unit Curie, which is C. Curie is defined as a mass of radioactive element which produces 3.7 into 10 to the power 10 disintegration per second. So this unit was discovered by Madame Curie, who is the eminent scientist handling the radioactive materials and got the Nobel Prize for the radioactive substance. He and his husband. Okay. So Curie is defined as a mass of radioactive element which produces 3.7 into 10 to the power disintegration per second. That means radioactive molecules are highly radiating. That's why they are disintegrating lots of number of elements or alpha or beta particle in a very small time. Slide. Now, other common units of radioactive material is also gray. It is known as the GY. So, to measure the absorbed dose, the amount of energy actually absorbed in some of the material, and it is used for any type of radiation. Any material does not describe the biological effects of the different radiation. So, it will be discussed by the formula. It will be explained by the GY equals to joule per kg. That's 1 joule energy deposited in 1 kg of the material. That means whatever the energy will be required to radiate, it will be known as the gray. Now, other radioactive units are Röntgen. That was also discovered by a scientist named the Röntgen. I cannot recall the full name, and it is used to measure the exposure, but only to describe for gamma and X-rays, and only in the air. So Röntgen will be like units having value. Depositing in dry air enough energy cost 2.5 into 10 to the power minus 4 coulombs per kg. That means per kg of the material will be producing 2.58 into 10 to the minus 4 coulombs of the energy in dry air if we measure the radioactivity in dry air. Now REF, that is the Röntgen equivalent mass, that is the mass, to derive the equivalent dose related to the absorbed dose in human tissues through the effective biological damage of the radiation. That can be calculated if there is any damage to the human tissues. That can be calculated through the REF. Now another units are there, Sievert and Becquerel. So Sievert is the to derive equivalent dose, the absorbed dose in human tissues to the effective biological damage of the radiation. This is the SV equals to GY into Q. Q is the quality factor unique to the type of the incident radiation. So that means it will be calculated the absorbed dose in human tissue, the effective biological damage of the radiation. That is also calculated for the damage produced by the radiation in the human tissues also. Now Becquerel, that is also a unit of radioactivity. The quantity of the radioactive material that have an 1 transformation per second. So Becquerel will be producing 3.7 into 10 to the power 10 Becquerel or 1 Curie per second. That will be measuring this type of disintegration unit. Now detection and measurement of the radioactivity. The radioactivity of the radioactive substance is detected and measured by some instrument that is known as the Geiger-Müller counter, that is GM counter, Wilson cloud counter, scintillation counter, dosimeter. These are the instruments where the radioactivity can be measured. Showing the diagram. This is the Geiger-Müller counter. Here is a cathode and anode placed. An ionized gas atom is there and ionizing radiation. In this tube, radioactive material will be there. There will be ionized gas which will helping to disintegrate the radioactive rays alpha beta, and ionizing radiation will be measured through our detector like any amplifier or any potentiometer, and it will be showing the disintegration. So this is a scintillation counter. Actually, it will be amplifying. Okay. So the mechanism is showing here. So here, incident particles are fall upon a ionic plate, and luminous photon will be emitting. So whenever they will be reflecting through some cathodes and anodes, they will be polarized and they will be amplified and giving a larger amount of ray, which will be first primary or tertiary or secondary, then which will be fall upon a detector. So here instrument will be there, pulse discriminator or digital counter, like multi-channel analyzer or coincidence circuit, that will be showed up on the computer. That will be a display through a screen. So this is a light screen, and then photo detection will be here. This is a photo cathode where the luminous photon will be falling on. There is a light curve. Actually, small pore will be there so that the photon will not be discreted. It will be single channel. The light guard and optical contrast will be there. As a result, the photon or the radioactive light will be passing through only one pore. Now, types of radioactive rays. So, we have discussed very small bit. Now, we are discussing elaborately alpha, beta, and gamma rays. Okay. Now, alpha rays or alpha particle of the helium molecules, helium nucleus, whose mass number is 4 and nuclear charge number is 2. Alpha particle decay. For proton-rich heavy nuclei, which have the larger proton in their nucleus, a possible mode of decay to more stable is by the alpha particle emission. So that means they are the heavy nuclei with the proton, they will be showing the tendency to release the alpha. Okay. Now, when a radioactive element elements an alpha particle, the mass number of the daughter element is decreased by 4 units and atomic number gets decreased by 2 units. Like polonium to palladium. So you can see 82 to 24 and 250 to 151. As a result, one helium particle has been produced. Now, beta decay. Beta particle denoted by beta is a fast moving electron is emitted from the nucleus of an atom undergoing radioactive decay. Beta decay occurs when a neutron chunk changes into a proton and electron. Okay. Many neutron-rich radioactive nuclides decay by changing a neutron into parent nucleus into a proton or emitting an energetic electron, like polonium that will be converted to At, antimony, and the dioxin and particle. Now, gamma rays are not charged particle like alpha and beta. Gamma rays are the electromagnetic radiation with high frequency. They do not have any atomic number and mass number. And when atoms decay or emitting by alpha or beta particles to form a new atom, the nuclei of the new atom formed may still have a launch of to decay the energy of the nucleus. So they will be forming a energy stable molecule. This excess energy is emitted as gamma rays, and they have an energy near about 1 into 10 to the power minus 12 joule. These are the different properties: the nature, the charge, the mass, the speed, and the ionizing effect, and most dangerous. Okay, so that has been discussed alpha, beta, and gamma. And charge will be like alpha having 2, beta minus 1, gamma is 0. Mass, alpha having relatively larger mass, beta having very small because electrons do not have the mass, and gamma no mass. Speed of the alpha particle is slow because it's a heavy particle. Beta particle is having very fast because it is electron. Electron can rush very fast. Speed of the light, gamma having electromagnetic radiation, that's why the speed is very high. Ionizing effect, that is strong ionizing effect alpha, it can ionize any particle in larger way. Beta particle having a weak tendency of the ionization, and gamma particle cannot ionize anything. So most dangerous when source is the inside the body. If alpha particle is inside the body, it will be having dangerous effect, and beta particle will be affected outside the body when, and the gamma particle also, the source outside the body, will be showing effects in the tissues or human body. Half-life. Now, half-life of the radioactive nuclei is T-half, known as the T-half. That is the time taken for half of the nuclei present to disintegrate. Suppose 5 gram of the radioactive element has been taken. It will be disintegrating to 2.5 gram. That is known as the, and within which time? Like it will be taking 135 years, 145 years. That is known as the T-half. Okay? And it can be represented very slowly. That is N equals to N0 by 2. That is number of atoms will be decreased to N0, that is the initial of atoms. Okay. Next, therefore the equation N equals to N0 into e to the power minus 8, where N t to the power half will be having the equation 0.693 K. With this, you can calculate the half-life of any radioactive material. K is the constant. See, so the example of this radioactive particle. Now, isotope that you know very well, isotope are the number of different mass number with the same atomic number. The number of proton and neutron combined together is called the atomic number. Sorry, mass number, where the total number of proton is the atomic number of an element. So, if some of the molecules are in the same atomic number, they are known as the isotope. Example of isotope oxygen 16, 17, 18. They have the proton number of this 16, 17, 18, but they have the mass number different. Okay. So, same atomic number but different mass number is known as the isotope. Uranium 235 to 38, rhodium, hello, hydrogen, 1, 2, 3, deuterium is one of them. Okay. Now, properties. The properties will be discussed in your class. Chemical property, physical property. You have to study. Types of isotope. There are different types of isotopes are present. Stable isotope and unstable isotope. They are used for different scientific performance, environmental experiment. Oxygen, hydrogen, sulfur, nitrogen, and carbon. For example, in geochemistry, scientists study the chemical geological substance, some metal rocks, some minerals. Okay. They are used for the geological. Now, radioactive isotopes, they are used for the long-lived radioactive, for the anthropogenic activity, cosmogenic radioactive for the space-related function. Storage condition, they have to be stored in very polythene or a suitable plastic container or glass vessel that will be preventing the radiation. That will be not preventing, that will not radiate, that will not diffuse the radioactivity. So there are different uses. Carbon dating, uranium isotope used for the nuclear reactor, radioactive isotopes are used for medicinal purposes like the arsenic, blood clot, tumor detection. Cobalt, they are used for the cancer treatment, iodine, goiter, thyroid gland. So these are the sodium iodide, these are the different radioactive materials description. Certain precaution must be taken. Food, the food material should not be taken by the radioactive activities or and support sufficient protective shielding should be there. Prevent the radiation, area of the area stored should be very supervised, and their disposal may also be done with great care. Hazards, there may be properly, there are hazards like infection of cancer, genetic effects, and tumor, fetal embryo, lactating mother should not be exposed to this. Now, there are radioactive contact media are there like the barium sulfate. Okay, that will be discussed in your next class. Various bones, cartilage will be detected through MRI through this radioactive contact media. These are the radiosodium iodide. They are the of their preparation method, their properties, and things are there. Hypothyroidism treatment is done by the iodine. Next, sodium iodide is used for different injection. Just there, barium sulfate is radioactive media. It is used for MRI, CT scan. Properties, identification test is there. Uses now. Thank you for listening, and you have to study and you have to take the notes from your books, and you can take note from the books also. So thank you all for listening.